Okay. So we are now we're out of matrices, and we are now, we're now in sequences and series. So we're starting a whole new unit, but we have learned all this in Sec 3. It's just been forever, and it can tend to be a little bit of a harder topic for people sometimes, so just pay attention. I feel like it's going to be pretty easy for you. At this point, our abilities have grown a lot. Okay, so we're going to get into 12.1, the basics of a sequence, and then we're going to talk about summation notation. So it says, roughly speaking, a sequence is an infinite list of numbers with a specific pattern. So in this first lesson, there's just going to be, depending on the problem, some pattern. It's not going to be the same pattern every time. So for example, 5, 10, 15, 20. What's the pattern? We're adding 5 each time, right, in this particular one? So that's just a sequence of numbers, and then the comma, dot, dot, dot means that same pattern continues forever. So if I asked you, what would the next term be here, what would you say? 25, right? And so on, and so on. Okay, cool. Now we have to understand really, really well notation for this. This is what I think can either make or break it. So notation. This a sub 1 means the first term. Does everybody see? So this 1, notice, is not a 1 here. That just 1 means first term. So right here, this is a sub 2. That means the second term. A sub 3 means the third term. A sub 4 means the fourth term. So if I said to you, a sub 7, what term am I asking you to find? The 7th term. So if I asked you to find the 7th term, what would it be? So right here would be a sub 5, wouldn't it? So then after that we'd have a 30, then we'd have and that would be our a sub 7, our 7th term. So our answer would be 35. Okay, so now we have to understand how we write generally speaking here. So that a sub n is the nth term. That's generally speaking. So nth term can be any term. Then if that's true, guys, a sub n, the term that came before it would be a sub n minus 1. Now think about why that is. If this is 3, won't this be 3 minus 1? 2. Does everybody see? So when you see this, guys, now the minus 1 isn't like this. This is not a sub n and then minus 1. It's a sub n minus 1. The n minus 1 is down here. So that just means when you guys see that, don't take it literally. That literally means the previous term. So everybody remember that. That's hugely important for us. So if you were to see this a sub n plus 1, that just means the next term, which makes sense, right, everybody? If this is a sub 3, this would be 3 plus 1, which would be the next term after a sub 3. So anytime we're going to see a sub n minus 1 a lot, that just means take the previous term. So let's test your knowledge real quick. If a sub n, if I'm telling you a sub n is 15, if I say to you what's a sub n minus 1, what would you say? 10, because that means what's the previous term. Does everybody see? All right, if I said what's a sub n plus 1, we're talking 15, people. 20, that means what's the next term. Does that make sense? Okay, awesome. So now let's look at, we have 5, 10, 15, 20. We can write 2 types of formulas for this. There's what's called I call it a direct formula. It's the straightforward formula. You can straightforward calculate getting 5, 10, 15, 20 out of it. And then there's also what's called a recursive definition, which is a formula also, but it's a formula that's written in terms of the previous term. So guys, what a formula does is it allows you to give it to someone that doesn't know this, and then from that formula, they could recreate 5, 10, 15, 20. So if you gave someone this formula, this direct formula, we can plug directly in. See, look, if you said, well, what's the first term? That's a sub 1. You would then see, look, a sub 1. You guys see what we do? Plug in a 1 for n. So that'd be 5 times 1, which is 5. Does that make sense? So then you'd say, well, I need to know the second term. A sub 2, so that'd be plugging in a 2. So then 5 times 2 is 10. You guys see how then people can recreate that same sequence? And so on and so forth. A sub 3, plugging in a 3 would get you 15. I think you guys get the picture there. So now a recursive definition is another way for someone to recreate that same 5, 10, 15, 20 without knowing that's what you were given. So look at this formula. This says any term in the sequence, that's what A sub n means, any term in the sequence. So this says any term in the sequence will be equal to A sub n minus 1, which doesn't that mean we have to take that literally as previous term. So this formula is written in terms of the previous term. This says take the previous term and then add 5 to that. Now if you are doing a recursive definition, for someone to recreate this, they would need to know where to start. So then we say starting with A sub 1 of 5. So then look how somebody could take this and rewrite this. They'd say, okay, I'm starting with A sub 1 is 5, comma, then the next term will be, well, you take the previous term and add 5. Isn't the previous term 5? 5 plus 5 is 10. Now to get this term, you'd say, I take the previous term, which is 10, and I add 5 to it. 15. It's just getting to the same thing different ways. Does that kind of make sense, everybody? So a direct formula and a recursive definition. Recursive is a formula that's written in terms of the previous term. Okay. All right, so this, you can just watch. I don't think you are going to need to take notes. You're going to get more out of this one just watching. It says, write out the first 5 terms of the sequence. So you say, I'm going to do A sub 1, A sub 2, A sub 3, A sub 4, A sub 5. Now, isn't this a direct formula? So don't we plug directly into it? So plug in 1. Don't we get 2 times 1 minus 1? 1, comma, plug in 2. 2 times 2 is 4. 4 minus 1 is 3, comma. Plug in 3. 2 times 3 is 6, minus 1 is 5. You guys see a pattern? So instead of plugging in, you can continue with that same pattern. So 1, 3, 5, 7, 9. Does that make sense? Okay, now let's go to the one below it. Now this is a recursive definition. So look, how can we create or write out the first 5 terms? So you'd say, okay, the first term is 3. We're told it's 3, comma. Now this formula says take the previous term, add 2. So won't that be 3 plus 2? 5. Okay, then this says take the previous term and add 2. 7. Take the previous term, add 2. 9. 1, 2, 3, 4, and then we're writing out the first 5. Take the previous term, add 2. Does that make sense, everybody? How to use this? Okay, so let's look right here. So this is a direct formula, so we'd plug directly in. So we're finding A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. So let's plug in a 1. That would be negative 1 to the first divided by 2 to the first. So the first term is negative 1/2, comma. Now plug in a 2. So that would be negative 1 squared divided by 2 squared, which is positive 1/4, comma. Plug in a negative 1 cubed divided by 2 to the 3rd power. Negative 1/8. I don't want to keep plugging in personally. Can you see a pattern? Bouncing between negative, positive, negative, positive. So the next one will be positive. On top, what are we gonna have? 1. On bottom, aren't we timesing by 2? This will be 16, comma. So then we'll have a negative 1 over 32. Okay, good. All right, let's do this one, and then we're doing good. So this says, okay, this is a recursive definition starting with the first term being 1. Now, we're taking the previous term, adding 2 to it, and then after that, timesing by 3. So let's do the math here. 1 plus 2 is 3. 3 times 3 is 9, comma. Now this, once again, look right here. Take the previous term, which is 9, isn't it? Add 2 to it, which is 11. 11 times 3 is 33. And I think we probably get the picture here. I'm not going to finish that one off. Okay. Awesome. So we just plug directly into our formula, or we just use our previous term and go for it. Okay. All right, so now these are actually the next 2 lessons. I'm going to give you a formula that works every time because it's a specific type of sequence. It's a specific type of pattern. So for right now, we're going to kind of just notice some things, and we're going to just, I'm going to just have you write a formula. This is kind of a guess and check thing. It's kind of hard to do that, but we're going to stay pretty basic. So I just want to make some things to note. If we have negative 1 to the nth power, that will create a bounce between positive and negatives from term to term. Think about why. If we have negative 1 to the first, that's negative. Negative 1 squared would be positive. Negative 1 cubed would be negative. So that would create a bounce of positive to negative if you had a negative 1 to the n in your equation. Now another thing to note, just for kicks and giggles, is 2n would create consecutive even numbers. Now consecutive means one directly after another. So skipping all the odds and going in order, that would be 2, 4, 6, 8. 2n would create that. And then 2n minus 1 creates consecutive odd numbers in a row. Consecutive means exactly in a row. So then our first odd number is 1. So then 1, 3, 5, 7. So think about why that would be. Look, if I plug in 1 right here, 1 times 2 is 2. If I plug in 2, we get 4. If I plug in 3, we get 6. Do you guys see how this 2n is creating us to skip the odds? And then think about it, if we take an even number and we subtract off 1 off of it, you're at the even point, now you're subtracting 1, now you're in the odd number position. So those are just little things to note. And so let's just see if you can use logical thinking to write let's write a direct formula for this. So look on top, 1, 3, 5, 7. Aren't those all consecutive odd numbers? So what was the formula that would give us that? So on top we'd have a 2n minus 1. Perfect. Now on bottom, 2, 4, 6, 8. Those are consecutive even numbers. So we would get a 2n. And that's my direct formula. Can I divide out the 2n's? No, because we can't divide across the subtraction sign. Okay, let's create a direct formula for this one. Now, this one is not necessarily going to be any of these. This one's like a critical thinking one. So it's 2, 4, but then it's not 6. Then it's not, do you guys see what it says? It's not consecutive even numbers. So this won't be this formula. Now what do we see happening? It's bouncing between positive and negative. So we're definitely going to have a negative 1 to the nth power in it. And then can anyone just guess maybe what formula would create 2, 4, 8, 16? Times by 2? And then what else would you want to add on that? Because that would work for our first term, but then how am I getting 4? To the nth power. 2 to the nth power. Think about why that works. If I plug in 1, I'd get 2 to the first. If I plug in 2, I'd get 2 to the second, which is 4. If I plug in 3, 2 to the third is 8. You guys see how we're just timesing by 2 each time if we do that? Okay, awesome. That was just critical thinking there. Like I said, though, later we will be giving you exact formulas that will always work, so that'll be nice. Now, you don't need to write this down. This is just a fun fact for you that was in the book. So, the Fibonacci sequence is actually seen all over in real-world settings. This pattern happens. Well, it's called the golden spiral. So, these are just examples of where the Fibonacci sequence pattern is happening. Can anyone see how they're getting those numbers by chance? 1, 1, 2, 3, 5, 8, 13, 31. Can you see it? How are they getting it? Yes. They're adding the 2 previous numbers before it. What's 1 plus 1? 2. What's 1 plus 2? 3. What's 2 plus 3? 5. 3 plus 5? 8. 5 plus 8? 13. Does everybody see? Cool. Not super important. Just showing you that it's used it's seen all over in real world situations. Okay, so now here is the thing. So far we've only seen commas in between terms. Now there are times when in calculus we would find it useful to insert addition signs, to actually add up terms. Instead of just having a sequence of numbers, to actually take and find the sum or add them up. So S stands for sum. So it's called a partial sum because we're going to just be adding up a partial amount of the sequence, not the whole thing because it's infinite, a lot of these. So it says find the sum. So S stands for, all you guys do, you don't even need to write that down. That's not a formula. It's just adding, look, take the first term, add it to the second term, add it to the third term, add it to as many terms as you want. So pretty straightforward here. So this is finding a sum, a partial sum. Now, once again, look, this goes on forever, but it says right here, what is the first 4 partial sums? So that means add up the first 4 terms. So you would do a half plus a fourth plus 1/8 plus, what would be the pattern? 1/16. So then from there, you would get a common denominator because we can't, really we should be writing our answer as fractions if you start as fractions. So to get a common denominator, wouldn't I times by 8 over 8. Wouldn't I times by 4 over 4? Wouldn't I times by 2 over 2? And now all my denominators are 16, so just remember that. On the bottom I'm going to have a 16. Now add up your numerators. 8 times 1 is 8. 8 plus 4 times 1. 8, 9, 10, 11, 12, right? 13, 14, 15. So it sums up to be 15 over 16. Okay, so let's read this. We're actually almost done with the lesson. It says, what is the first 4 partial sums? So in this one, we're going to want to go through real quick. That's a formula that gives us terms. We're going to want to go through and actually calculate. So let's find a sub 1. What do I do? Plug in 1. So look, that would be 1 over 1 minus 1 over 1 plus 1. I'm only going to show my work this first time because it was confusing for people when I didn't. So isn't that 1 minus 1/2, everyone? Then we're going to add that to our a sub 2. So then we would have 1 over 2 minus 1 over 2 plus 1. I actually showed my work twice. So that would be plus 1/2 minus 1/3. Okay, now let's just do it in our head. Plus, now we're doing a sub 3. Plug in a 3, so wouldn't that be 1/3? 1/3 minus, and then that would be 1. 3 plus 1 is 4. And aren't we doing 4 partial sums? So then plus, one more parenthesis here. Plugging in, that was a sub 4. Now we're plugging in a sub 5, aren't we? Oh, we just did a sub 3. I was going to say, that'd be the first 5 partial sum. Okay, a sub 4, so that'd be 1/4 minus 1/5. Now you could just type that directly into your calculator, but let's think advancedly here. Look what happens. Even though there's parentheses, it's just an addition sign in between, so we don't need to distribute anything. So don't we have a negative 1/2 plus 1/2? Don't we have a negative 1/3 plus 1/3? Negative 1/4 plus 1/4? So really, we only need to do 1 minus 1/5, don't we? So then from there, we would get a common denominator, so we times it by 5 times it by 5. So that'd be 5 minus 1 is 4. So the answer is 4/5. The sum adds up to be 4/5. Doing really good here. Okay, we're almost done here. Last thing, this is what's confusing to people, so focus. It's called summation notation. It is easy, but you do have to really, really understand it and have no misconceptions. So guys, summation notation is the exact same thing as saying take the sum. It's just writing it in a special way. So let me explain here. When we take 2, 4, 6, 8, 10, and we turn it into a sum, a partial sum technically, that would be 2 plus 4 plus 6 plus 8 plus 10. Does everybody see? I've turned it into a sum. There's just another way to write out this exact same thing, another way to format this. And that's what's called summation notation. So we'll come back to that. So how we write something in summation notation is we put a sum sign. Guys, this means add. This is a sum sign. So when you see this, that means add. Just like we see these addition signs here. That sum sign means add. Then what you put down here is what we call a lower limit. Now understand, a lower limit is just what term are you starting at adding. So right here, this is like how many terms are you going to sum up? Well, I'm summing up the first through the, and then the upper limit is the stopping point. How many terms you are stopping adding at. And then in here goes the equation that would create the 2, the 4, the 6, the 8, the 10. So the equation that would recreate that sequence of numbers. So looking at that, let's see how we could take this 2, 4, 6, 8, 10 being added and write it instead in its summation notation. So because of the add signs, we put our sum sign, everybody. Does everyone see? Now this is our first term, second term, third term, fourth term, fifth term. Now guys, didn't we start at the first term? So my lower limit is saying n equals 1. This means we are starting at the first term and adding up to the, we stopped adding at the fifth term. So notice 1 through 5. Did that have anything to do with our numbers in here? No, a lot of people think it does. So this is means the fifth term. The fifth term is where we stop adding. And then what are we adding? Well, 2n is what recreates 2, 4, 6, 8, 10. Weren't these the consecutive even numbers? Which we found out was formula 2n. See, if I plug in, look, if I plug in 1, I get out 2. Does everybody see? If I plug in 5, what do I get? 10. Does that make sense? It's not doing anything different. They are the exact same thing, just two different ways of writing it. Okay, so when you see this, this literally says, find the sum from the first up to the third term, given this formula. So let's go ahead and write this one out. It is asking you to find the sum. So let's write it out in its other notation. So if we're starting with 1, plug in 1, so that'd be 2 times 1 squared, which is 2. Does everybody see? Plus. Now we'll plug in 2. So then that would be 2 times 2 squared. 4 times 2 is 8. Plus. Then we're stopping at the third term. So that'd be plugging in a 3 right here. So then 2 times 3 squared. 9 times 2 is 18. So do you guys see how this says find the sum of the first through third term? And that created 2, 8, 18. So then that would be 18 plus 10, which is 28. So the answer is 28. Okay, let's do this one. Now look, in this one, we're starting at the third term. Do you guys see? And we're stopping at the fifth term. So we're going to start at a sub 3. Does everybody understand that? So then 3 minus 2 is 1 plus, then we're doing a sub 4. Plug in 4. 4 minus 2 is 2 plus, then we're stopping at a sub 5. 5 minus 2 is 3. So our sum comes out to be 6. 3, 4, 5, 6. Okay, let's see if we can think of a way to rewrite these in summation notation. So it's not asking you to find the sum. This in the instruction says, instead, we want you to write this in its sigma notation or summation notation. So everybody, you'd say, I see I'm adding, so that means I have a sum. Now, I personally, looking at this, what formula here would create? What's happening? Like, how can we recreate 1 cubed, 2 cubed with a formula? N cubed, right? 1 cubed, 2 cubed, 3 cubed. You guys see? We're just kind of putting 2 and 2 together using our logical thinking. Well, if that's true, what would be our lower limit? N equals 1. Are we plugging in 1 first? And then we're going up to 7 terms. Does everybody see? Okay, awesome. Let's do this one. So I'd say, oh, this is to find the sum, so I put my sum sign. Now let's put our formula here. What's recreating this? Square root of n. Great, I like that. Now if that is true, then what would have been my starting number? So n equals 3 up to 7. Okay, last one. Find the sum. Now somebody asked me, what if you want to call this your first term? That's fine, we got to change your formula. So you'd say, okay, this is my first term, second term, third term, fourth term, this would be my fifth term. If you start with 1, you guys see? So then if you said n equals 1 to 5, that's true as well, but then your formula's got to be different. So what if you're plugging in a 1 would have to be in here to create 3? N plus 2, wouldn't it have to be? 1 plus 2 is 3. And then if you plug in 2, you get 4. And if you plug in 3, you get 5. So then you would have this answer. Both answers are equally correct. Just different ways of writing the same thing. They do calculate to be the same thing. All right, so we here have 2, 4, 6, 8. Aren't these consecutive even numbers? Well, if that's true, then our formula is 2n. We're summing up the first. Isn't this, if this is 2n is our formula, aren't we doing first? So n equals 1, and then what goes on top? A lot of people have this temptation to put 20. That's not what it is. How many terms are we summing up? 10 of them, right? We're skipping the odds. If there's 20 of them, half of them are gone. You guys see what I'm saying? So you'd say 10. Okay, awesome. Very, very good. That is the end of the lesson. So what I want you to do before we move on is go do 12.1, these problems. This is not on your paper. I had to add it on to introduce you before we move on to 12.2, to the basics. So just go do these as quickly as possible, and then we'll move on to 12.2.